So this is another probability question. Turns out we had 2 probability questions in a row. Not really, it just happened to work out that way, random chance. So what we've got is there are how many bills in this wallet? We've got 5 $5 bills, 7 $10 bills, and 8 $20 bills. So if you add that all up, it looks like there are 20 bills in this wallet. And let's say these are all shuffled up. Now, I was looking at this earlier and I was thinking that's actually a lot of money to carry around in your wallet. That's let's see, that's 160, that's $230, $255. That's quite a bit of money to be carrying around in your wallet, but in this case, it happens to have that much money in there. And the wallet owner decides to reward the finder and they just draw a bill randomly from the wallet. What is the probability that the bill drawn will be a $20 bill? Well, there are 8 $20 bills. I'll just circle that one again. So that means out of the 20, that's 8. And now this is the probability, but you'll see that's not any of our answers over here. So we need to do something more. What we're going to do is simplify this. And we could simplify all the way down to the simplest fraction if you already know what to divide by. But I noticed, first of all, that this can be divided by 2. And so that gives me 4 out of 10. Again, that's not an answer choice, but I can see that I can divide this even further. I'm going to divide this by 2 again. And that gives me 2/5. Now this seems to be as simple as I can get that fraction to be. And sure enough, that's my answer D. So from the beginning, I could have just divided this 8 and 20 by 4, and I would have gotten my final answer. But we can do it either way. So what we're going to be looking at today is, it says quadrilateral properties. We're going to look at those. We're going to focus on one in particular, and we're eventually going to be answering this question. When you look at a diagram, is it a parallelogram or not? And we're going to not just kind of look at it and estimate. We're going to be using this midpoint formula here in order to tell us if it is a parallelogram or not. So let's start with the quadrilateral properties. And we introduced these yesterday. I'm not going to talk about these in any detail except to say that today we're talking about this particular property. The diagonals bisect each other and they cut each other in half. We talked about what that means. These 2 segments right here, let me mark them. These 2 segments are going to be congruent. These 2 segments are going to be congruent. And we're going to kind of look at it from a different perspective, but we're going to use this basic property to diagnose if a random quadrilateral that I give you is a parallelogram or not. So very good. Let's go ahead and look at this. We need to first of all talk about the midpoint formula. Hopefully this is not the first time you've been exposed to this, but I do understand it's probably been a while since you've seen it. So we'll talk about it for a second. If you do have 2 points on a graph, you can create a segment between them. So we're going to start with these 2 points, 4, 6, which is this point right here, and -5, -2. -5, -2. All right, and we can create a segment between those. So that's what I'm going to do. Hopefully I can do this pretty well. That's not too bad. So I'm just freehand drawing that, so it's only going to be approximately in the right spot. Now this segment has a particular midpoint. We could estimate where that's at. I mean, it's probably going to be in this vicinity over here, but we can get the exact midpoint using the midpoint formula. And there it is. So this is basically saying I want to get the average x value, and that's going to be my x coordinate, and I want to get the average y value, and that's going to be my y coordinate. So we'll see how that works. I'm going to bring these 2 points down. I've got 4, 6, and I've got -5, -2 down here. And it doesn't matter which one we call which, but notice that they're talking about x sub 1 and x sub 2 right here and here. That just means the x value from your first coordinate, the x value from your second coordinate. So I'll call this one x sub 1, and that can be x sub 2. And that means for the y values, this would be y sub 1. That would be y sub 2. Okay. So and again, if you mix those up, if you switch which one you call 1 and which one you call 2, that does not change the formula. So now I'm just going to start plugging stuff in. So it's straightforward. It's taking this 4 right here, which is x sub 1, plugging it in right there. Taking x sub 2 and plugging that in right there. Now we actually have two different expressions, two different calculations to do. So if I'll go ahead and plug it in. I got 4 plus -5 over 2. And that's my first calculation. The second one, because I'm going to get an x coordinate out of that. The second calculation is taking my y values. So it's going to be these plugged in to the second calculation. That's going to be 6 plus -2 over 2. So let me finish the calculation, then we'll talk about this equation a little bit more. So 4 plus -5 is going to be -1 over 2. 6 plus -2 is 4 over 2, which leads us to our final midpoint of -1/2, 2. So if I go -1/2, 2, it's right here. So my line didn't go in a perfectly straight line, but if it did, you'd see that's, falls in that region I thought it would. So the question that some people were having from first class and maybe in this period as well is, why are we dividing by 2? And that's just a part of the formula, first of all. But we divide by 2 because we're getting an average between two different x values. The average is going to be the middle value between two extremes. So it's just like if I was to take, my age and your age, and I wanted to get the average age between us. So I'm going to assume most of you are 16, and plus or minus. And I am 36. So if I wanted to get the average age between us, then I could just add that up and divide it by 2. And that gives me 52 divided by 2, and we get 26. So the dividing by 2 is just a way of saying, let's get the average x value and the average y value. And that's going to give us the point that's right in the middle. So if that part makes sense, I'm going to move forward. If any of this stuff you still need to go through some extra examples at the end of class, please let me know. If any of the stuff you're not sure why we're doing plugging numbers in a certain way, just let me know any of those questions that you have. But we're going to do one more example right here. And notice that I do have the graph for these problems, but we're going to find that we don't actually need the graph for this. And all we need are the coordinates. So here's the midpoint formula again. Here's the point we're going to use this time. -9, 8, which is right here, and 3, -7, which is that point right there. I'm going to draw a line that's hopefully pretty straight. Let me try that one more time. All right, it definitely has some curve to it, but it's decent enough. So I want to take these points. Here's my first x value, x sub 1. And this is my next one, it's x sub 2. This will be y sub 1 and y sub 2. And I just want to plug these in. Okay, so once I've got those numbers ready, that in my head, I'm mentally ready to plug those in. Let's go ahead and do it. -9 plus 3. Notice that I took the 9 and the -9 and the 3, plugged it in, divided by 2 over, and then the next one is going to be 8 plus -7. Again, it's these two values right here, divided by 2. So -9 plus 3 is going to be -6 over 2. 8 plus -7 is going to be 1. So now I can do -6 divided by 2 is going to be -3, 1/2. So let's see if that makes sense. -3, 1/2. It's that point right there. And now just visually looking at it, we could agree, yeah, that looks like it's about the middle. And I drew my line well enough that it seems to be in the right spot. And so that point matches well enough. Okay, so that's kind of the midpoint alone. Now let's jump to part of your homework tonight. I want to show you. Before we look at this, if it's a midpoint or not, we're going to come over here to Delta Math. And I wanted to show you real quick that we've got your problems tonight. You're going to have 5 of these. And I just give you 2 points. I could come up with a new problem. Of course, Delta Math will just make it up. You're going to get 2 points and you need to plug it into your formula. So if we looked at this one, it could be 10 plus 2 divided by 2. That's the first, your x coordinates. And then I'm going to take the y coordinates, these 2 that I'm circling, 10 plus 6 divided by 2. And from there, you can do the math. So get some practice using your midpoint formula. All right. So that's going to be your Delta Math today. Now let me look at this. We're going to put this into context now with your parallelogram. Okay, so here's a shape. It could be a parallelogram, it could not. And you might already look at this and know the answer. But, sorry, I was just reading something in the chat. If you got to go, that's fine. I understand some people have other things going on. Okay, so anyways, you might already be looking at this shape and already be able to tell me, no, that's not a parallelogram, or yes, that is a parallelogram. So you might already have an answer, but we're going to confirm everything. And the way that we can do this is I just want to get the diagonal, the 2 diagonals from this parallelogram and get the midpoint of it. If the 2 midpoints are the same, then we have a parallelogram. If they're not, then we don't. So we're going to do 2 examples. And again, if you look at this and you already know that it is or isn't a parallelogram, that's great. We can confirm that here in just a second. So there's one diagonal cutting across. I'm going to go ahead and label these points with their coordinates. So point B is at -3, 5. That's -3, 5. And point D is at 3, -2. We'll worry about the other points in just a second. So let me do the midpoint for the first diagonal. It's going to be -3 plus 3 divided by 2. That's from these 2 coordinates right here. I took the x's. If it helps you to actually label them, then you can actually label this as x sub 1, x sub 2. And then you have y sub 1, y sub 2. All right, so now I've got, for the next one, it's going to be 5 plus -2 divided by 3, or divided by 2, I'm sorry. It's always divided by 2. I just misspoke. Okay, so now -3 plus 3 is 0. 5 plus -2 is going to be 3. And my final coordinate here is going to be 0. 0 over 2 is just the same as 0. And then I could keep this as 3 halves if I want. I could write it as 1 1/2. I could write it as 1.5. Here, it doesn't really matter how you choose to write it. I'll just write it as 1 1/2 for right now. Okay, the other diagonal goes like this. I didn't draw that very well. Okay, I got a little bit off, but it's close enough. All right, so point C is at -6, -2. Point A is at 5, 5. So if I call this one x sub 1, y sub 1, this could be x sub 2, y sub 2. And I'm going with the 2 points that are opposite each other because I'm creating the diagonal. I want to get the midpoint of the diagonal. So for this one, it's going to be -6 plus 5 over 2. And the other is going to be -2 plus 5 over 2. Again, I'm getting those points from the coordinates. -2 plus 5. That's where those numbers come from. Okay, so if we've got this, that means I'm going to get -1 over 2 and 3 over 2. And I could call it good right there. Just to put it in the same thing as before, it's -1/2 and then 1 1/2. So just so these two look the same. So the 1.5 is the same between the two, but the x coordinate's a little different. This is going to be, the midpoint for this one is right here. The midpoint for the other one is right here. They don't land on exactly the same spot. Therefore, this is not a parallelogram. It's close, but not quite. So like I said at the beginning, you might have already looked at this and been able to tell me it's not a parallelogram, but the main purpose of this is to get practice using the midpoint formula. And like I keep saying, if you need more examples after we're done with this, please just let me know, stick around, and I can go through some more examples. Okay, so we're gonna look at another parallelogram now. And just like before, you might immediately look at this and say, yes, it's a parallelogram, or no, it's not. But just like we did before, we're going to figure it out using the midpoint formula. So I've got, I'm going to go ahead and label all the coordinates first of all. This is 5, 5. This one's -6, 2. Looks like those two coordinates actually didn't change from the last example. But now B is at -4, 3, and D is at 3, 0. So I can pick any two of the opposite points and find the midpoint of it. I'm not going to draw the diagonals on here this time, but I will work with these 2 points. I'm going to start with A and C. So if I do that, I can take my 2 x coordinates. I'm going to do this a little bit faster this time. So if I look at my 2 x coordinates, it's -6 plus 5. Again, just look at the x values of those 2 points. You can see where those numbers come from. Divide that by 2. Now I'm just going to look at the y values alone. That's going to be 2 plus, that's -2 plus 5, which gets me divided by 2. All right, let's go ahead and evaluate this. -6 plus 5 is -1. -2 plus 5 is 3. And I think for this one, I'm just going to leave it like that. I'm not going to worry about simplifying the 3 halves or anything. I mean, that is as simple as it can get. I'm not going to rewrite it as a mixed number. So now let me find out where the midpoint is for this one. I'm going to look at B and D. So if I take just my x coordinates right here, that's going to give me -4 plus 3 over 2. And just my y coordinates is going to be 3 plus 0 over 2. So that means -4 plus 3 is -1. And 3 plus 0 is 3. And it looks like that's my coordinate. Now if I compare these two, and this is something if I compare those two, I can see that those two are exactly the same. So -1/2, 3/2 is going to be right about here. And that is the midpoint for both of the diagonals. And so that means that point is on the line. So I can now actually kind of sketch the diagonals at this point. So they are going to both cross right there. They're going to meet at that point, and that means that they cut each other in half. So if that makes sense, you've got some delta math problems where you just need to practice doing the midpoint. You also have some problems where you're going to be finding out, is this a parallelogram or is it not? And let me show you real quick. You have 2 parts of this assignment. One of them is on delta math, one is on Canvas. Let me jump over to the, I don't have it pulled up yet. I did have it pulled up and then I lost it. If I go to the modules, for today, you'll see both of them, and I'll make sure I'm in student view so that it looks the same. There you go. Sorry about that. Delayed a little bit. So notice right here, you've got 2 assignments associated with today. One of them is the delta math. And if you click on that, it's just going to say, basically go to delta math and do this for this assignment. And then the next one is your Canvas assignment. This is one that needs to be submitted on Canvas. And you'll see there are 6 problems here. You only need to do the even problems, all the evens. So there you go, 2, 4, and 6. And you can see the instructions right here. Is this a parallelogram or not? Calculate the midpoints of each diagonal to confirm. So you need to take these 2 points, just like we did before. So at this point, if you have any questions, if you need to see another example or more help with the midpoint formula, anything, let me know. If you feel like you understood what today's task is, then you can have a great day, and I will see you guys tomorrow.